some of the content that's covered in Chapter 5. And there's not a whole lot covered in Chapter 5. It's mostly just syntax and style issues. So what we're looking at here is the default, pretty much the default boilerplate that BlueJ puts into a new class when you create it. I've modified a few things, but we'll start with this. So these are the comments, that multi-line comments. The /* is used so that you can something called JavaDoc can be used, which we can ignore for now. But just go ahead and do. If you need a multi-line comment, you can do it like this with /*, and then end with a // right? And keep your comments short. These are too wordy as far as I'm concerned, right? But you definitely want to have a little something at the start of your class that says what it's for and your name and perhaps the date. All right, so we have one class called Chapter 5 here. Classes always start with a capital letter, right? And if they're multi-word, then each letter each first letter of each succeeding word is also capitalized. So you could do Chapter 5 like that, right? In which case I would have to change the constructor down here to 5 as well. All right, so classes always start with a capital and use that naming convention where the first letter of each word is also capitalized. Now, variables, right? X. So in general, we want to use meaningful variables. These are variables that tell us something about what the variable stores. So X, in some situations where for like a loop variable or for just a temporary variable, X is going to be fine, right? But normally we want to say something like, like size or hat size or something, right? If we had hat size, shoe size, right? When we're doing books, it was a number of pages and current page. And we were doing cards, it was suit and rank and point value, right? So those are all meaningful. They help. The computer doesn't care, but they help us, the human being, the programmer, read this code and make sense of it. Okay? And variable names always start with a lowercase letter, as do except for the constructor here, as do usually method names, right? And each succeeding first letter of a word is capitalized. No spaces, obviously. All right, here's a declaration of a constant, which I talked about in a previous video. The word final tells us it's a constant once this variable has its size set. In this case, the constant name is size. This constant size cannot be changed anywhere else in the program after initializing it here. And constants are usually all caps. Okay. And okay, so now we're down to the constructor. And since we no longer have X, we'll say, we'll put X back because it just will make things easier. We'll keep X. And we have X equals 0 here. Now, I want to go over something that was covered in the lecture by the Stanford professor quickly here, just because this is an opportunity to do it. X plus plus, right? We all know at this point that that adds 1 to X. But as was said in the lecture, this is really a method plus plus, right? And it doesn't look like other methods, but nevertheless, think of it as a method. And that method takes a single parameter, in this case, the X, right? And the method returns the current value of x, even though it changes the value of x, but not before it returns the current value. That's because the plus plus is after the x. I could put the plus plus before the x, in which case it would change it. It would change it first and then return the new value. So let's take a look at this. Println x plus plus. So what I've just said is true. This will output 0, even though after this line, x will be 1. So let's compile that and just see what happens here. And look, there it is. It's 0, right? But if I go and inspect this now, x is 1, because it did in fact change x, even though it output 0. Now let's just move the plus plus before prefix instead of postfix, and compile that, and should output 1. And it did. And if we go and inspect, it's 1, right? So cool. So that actually turns out to be very useful in arrays, because we can place x as the subscript, the x plus plus is the subscript, and that will refer to the current location. But after that line, x will be updated by 1 so that the next time we use it, it will refer to the next location in the array. Right? So it sort of moves down or across through the array very, very easily. Okay, so a quick side note on plus plus. Braces. A lot of you, I've noticed, like to do this and how you do your braces. That's okay. That's totally fine. That's an acceptable approach. I like this because it just, to me, looks cleaner. And one thing, right, to remind you, right, the computer, it doesn't charge extra for using lines. It's a flat fee. You can use a gazillion lines and it won't charge extra. So if you think this makes your code a little bit easier to read, then consider putting the braces on their own line. So the line between the code between two braces is called a block of code, right? And if we do loops, while x is less than 10, right? And you should know by now that if we're only doing one line inside of the a loop or an if statement, for loop, while loop, if statement. If there's only one line inside of it, we do not need braces, right? But that's very rare when we only have one line. So if we have more than one line, we need to do a set of braces, which creates a new block, right, or a subblock. And here we'd probably want to do something like x plus plus, so we approach our stopping condition. So we've got this outer block and this inner block, right? And this, as you write more and more code, you got lots of blocks, but you just need to make sure that braces match up. And yeah. Now, semicolons. What would happen if we put a semicolon there? What does that tell Java? Well, what it in fact tells Java that's the end of the while loop. And so this line down here, this block is no longer part of the while loop. It's just it's just some code that you put in a block, right? It's exactly the same thing as if we just had this code sitting underneath the while loop without like that. What this is really, in effect, doing is this, right? There's an empty block there, in effect. And so what's going to happen here is that would create an endless loop, because that loop, that's all there is to the loop. There's no change to the x values, so that we never approach our stopping condition, so we would just get stuck in an endless loop. So be careful about putting semicolons at the end of both the while condition, and same thing with a for loop. If I do this, semicolon, that ends the for loop, even if I have a block of code. Right here, which I think is inside that for loop. It isn't. All that's in that for loop is that the for loop ends right there. So this again is just code that's sitting unattached to anything else. Okay, there's not a whole lot more in chapter 5, right? Than this. I think there was one other thing I wanted to do. Oh yes, okay. There's one other thing, which is not directly related to chapter 5, but I thought I'd throw it in here. Right, we have a method here called sample method. I want to call that method from another method, so like from the constructor here, I want to call sample method. All I need to do in this case is, because it's a method of this class, right, I just write sample method dot, and pass in a parameter, right? And this is known as the actual parameter. That gets sent over to the formal parameter and plugged in, and so y becomes equal to whatever x was, and this will return x plus y to right here, and unless we do something with it, we'll do int z, so that z will now be have stored in it whatever gets returned from this call to sample method, passing in the actual parameter, which then gets returned, right? Or the whatever gets sent, the actual parameter gets sent into the formal parameter, the method does something and returns something, integer value. Okay, cool. So that's primarily what I wanted to do. The actual parameter is the thing you pass in. The formal parameters or parameter are where you define what you're expecting the method to have passed into it, right? And the actual parameter could be a literal constant like 4, right? As long as it matches in terms of the type, but it'll also be a variable. Oh, yes, and very last thing. When I said the sample method is a method of this object, or this class, right? You can actually, we talked about this before, but you can actually write the word this before a method, the name that's calling a method of the same class, right? And again, this is a way of Java sort of saying, hey, sample method is part of me, or this thing that's currently active. So the this keyword can be placed before both fields, which we've talked more about, but it can also be placed before methods. But there's no reason to do that if there's no confusion, right? If there's no other, like in the case of fields and parameters, they might have the same name, so you need to use this to tell it that you mean this object's field, not the parameter. But you can do the same thing with methods. Just sort of an aside there. And that is indeed, I think, all I wanted to talk about in this video. So, oh, one last thing, right? These are reserved words. So int and while, anything that gets highlighted, turned to color is a reserved word in Java.